Hey folks, and welcome to the second part of this video series on using Azure IoT Operations with GitHub Codespaces. So in the previous video that we did, we deployed Azure IoT Operations to a GitHub Codespace where we Arc-enabled a Kubernetes cluster, and that allowed us to be able to get Azure IoT Operations up and running. In this part of the video series, we'll be adding an OPC UA asset as well as an OPC UA simulator so that we can get some data flowing from our local machine or code spaces up to Azure IoT Operations and see how that data is working. So if you want to follow along with the previous video in this series, then you can check out the bit.ly just over there. And that'll take you through that whole sequence of events getting Azure IoT Operations up and running. So just before we carry on, if we have a quick look at the architecture here that we looked at before. So in the middle here, we had the Azure IoT Operations Edge section of services. And within here, we've got a couple of important services for this particular video where we have the Azure IoT MQ service, which is an MQTT broker at the edge. And we also have the Azure IoT OPC UA broker. So we'll be making good use of both of these with our simulator and adding an OPC UA asset. Likewise, on the left-hand side of the diagram over here, we've got our asset side of the equation where we have a couple of OPC UA servers which are connected to our OPC UA assets. So the assets here will be communicating with the servers, and the servers are then using OPC UA to communicate with the broker, which is then communicating to the MQ service over here. From there, then we can take our data through the northbound connectors and out to things like Power BI, Fabric, and other services like that. So we'll see some of this while we're running through this tutorial. So if I switch across to our browser here, so this is the tutorial we'll be running through. I'll put the bit.ly over there so that you can follow along with the Docs and Learn site while we do this. There's some information about getting started here, and that covers what I've just mentioned, where we're going to manually add an OPC UA asset, where these assets publish messages to the MQ preview broker in the operations cluster there. And then it describes what an asset actually is, and then describes about the OPC UA server as well. Obviously, we're going to need to have run through that first video. And again, the bit.ly for that first video is just over here, so you can go ahead and get that up and running. And then we're describing what problem we're going to solve here, where OPC UA servers expose a complex structure and can be difficult to understand. And Azure IoT Operations gives us a model to be able to give assets, tags, and events and properties. So quite important here is that we need to sign in to the Azure IoT Operations portal. Now, to do that, you can see in this blue box that it's actually telling us we're going to need a work or a school account to be able to do that. So for me, I've went over to my portal, and in Entra, you can create yourself a new user. So if I just show you that. So here I've got my IoT Ops user, and this is just a user within my own tenant. And within that user, if you go to Azure Role Assignments, you then need to give that user contributor access to the IoT Ops resource group. So whatever you named the resource group where your services are deployed in the portal in Azure, then you need to give your IoT Ops user, or whatever you call your user, at least contributor access to that resource group so that we can perform some of this functionality. And once we've done that, then we can go ahead and log into the Azure IoT Operations preview portal. So that's what you can see here. We'll see at the top right hand corner, this is my IoT Ops user that I've signed into here. So if you try and log in with just a regular Hotmail address, this won't work. You're going to need a work or a school account to make that work. So the other thing to make sure that you've done is that you've restarted your code space. So if you've gone away from that previous tutorial and come back, then likely when you open up this code space again, it's going to prompt you that it's stopped, and then you can restart it and you'll be in a state pretty much like what you can see on the screen here. So you should be good to go at that point. So returning to our tutorial, once we log in, we'll see that we need to select our site. Now we can group our deployments of IoT operations into sites, but we've not actually done that yet. So what it's telling us is that we can find our cluster that we created in the previous quick start under the unassigned instances option. So let's go ahead and do that. So we can press the Get Started button. And then we'll see here the unassigned instances sites here. So this is where we haven't actually assigned a site, an instance to a site. So let's click on that. And then we have our instances, and we can see here that we've got our cautious space yodel instance. So that matches our code space here, cautious space yodel, down at the bottom left-hand corner rather. So the next step will be to go ahead and click on that. And there we are. So this is actually the portal experience for our deployment of Azure IoT Operations that we did in the previous quick start video. So what we're going to do next is create an asset, but let's just go ahead and make sure that we follow along with the tutorial. And so we've selected our site now, and we've selected our instance. And the next thing we need to do is add an asset endpoint. So it seems that when we deployed Azure IoT Operations, we chose to include the pre-built OPC UA simulator, which is good. So we just need to add an asset endpoint for that simulator. So if we return to the IoT Operations portal, we can click to Manage Asset Endpoints and then create an asset endpoint. So we've got some data to add to this as well. So we've got the OPC UA connector 0 for the asset endpoint name, and also the OPC UA server URL. And then we've got user authentication mode as anonymous, and also transport authentication is do not use transport authentication certificate. So with all of those in mind, we can go ahead here and then we can hit the Manage Asset Endpoints button here. And then we can create an asset endpoint. And we can give it a name. So this one here. And I'm going to dash EP that as well because I like having an endpoint name. And then we can have this as the server URL. So that's what we took from the tutorial. And the user authentication mode is anonymous, and the transport authentication is set to do not use transport certificate. So we can go ahead and press create on that. And it's creating our asset endpoint. And then we can go ahead and view the progress of that in the notifications bar, where we're creating the asset endpoint, and we can just wait for that to finish. And that's finished creating our asset now and synchronized the changes down to our Codespace-based IoT Operations instance. So we can dismiss that. And returning to the tutorial, if we scroll down now, we've saved that definition. And this configuration deploys a new asset endpoint to the cluster. So we can use kubectl to view the asset endpoints. So let's go ahead and take a copy of that. And then we can have a look what that looks like. Keep working over here. And there we are. So we can see we've got our OPC UA connector 0 EP. So the next thing we need to do is configure our simulator. So these quick starts use the OPC UA PLC simulator. So to generate sample data, we use that simulator. So it gives us some data flowing through IoT operations. But we need to configure our asset endpoint to connect without mutual trust, which it says in that red box down at the bottom down here, But we shouldn't use this because we're going to expose our cluster to the internet without proper authentication. So I guess there's a proper way to do this. So we have a command here to patch our asset profile by the looks of it. It's worth bearing in mind that I've renamed my endpoint with a -ep, so we must remember to do that in this command as well. So let's take a copy of that. And then we'll run this, but before we run it, I'll just make sure I add the -ep to all of this. So just here, -ep, and also a bit further on, just here, -ep. Let's see what it does. So that's patched. And now we need to enable the configuration changes to take effect immediately. And so we find the name of our AIO OPC supervisor pod. And so we're looking for the supervisor pod, which is this one here, just there. That's the name. So I can take a copy of that. And then we can restart that pod using a command that looks like the following example, but we need to use the correct pod name. So let's copy that, delete pod. And we can run that command, but with our correct pod name in here. So let's just copy that again instead of, there we are, and then paste that in there. So that deletes that pod. No doubt we can see what that's doing. If we run the pods here, we should see that that OPC supervisor pod will likely have disappeared, and it has. But at the bottom, it's showing as running for 5 seconds. So we can see down here that we have our pod running for 5 seconds down here. So that's brand new and up and running now. So next, after we define an asset, an OPC UA connector in the pool discovers it, and the pod uses an asset endpoint that you specify in the definition, and we can use kubectl to view the discovery pod that was created when we added it. So that's that same get pods command that we saw there. And so the pod name looks like this just here, so AIO OPC TCP. So let's just make sure that that's there, and there it is. In fact, we can see that that was running for 9 minutes and 39 seconds, interestingly. So when the OPC PLC simulator is running, data flows from the simulator to the connector, and then to the OPC UA broker, and finally to the MQ broker. So next we need to manage our assets. So after you select your instance, you'll see the available list of assets in the assets page. If there are no assets yet, this list is empty. So now we need to create an asset. So we can go ahead and create the asset, and we can give it a name and an endpoint and a simulated thermostat asset description. So let's go ahead and do that. So we should have an asset endpoint in here now, and we do. So if we go back to the asset list, then we can see we don't have any assets. So we need to hit the create asset button, and we can give it a name like thermostat, select our asset endpoint, and then we can say a simulated thermostat. And what next? Remove the existing custom properties and add the following custom properties. Be careful to use the exact property names it says as the Power BI template in a later quick start queries for them. So we need a property name of batch set to 102. So we need to delete all of these. Like that. Then add a custom property called batch. And we need to set that to 102. And next, we need customer for Contoso, equipment and boiler, is spare and true, and then finally, we need location and Seattle. Okay, So we've got all of those added. So it kind of looks like that example image just there. So then we can press next to go to the add tags page. So here we need to create some OPC UA tags. So we can add 2 OPC UA tags to the add tags page. To add each tag, select add tag or CSV and select add tag. So let's copy this. And this is going to be temperature. So I can press next, add tag, and then add tag. And that's going to be temperature. Observability mode none. We'll leave both of those as the default and press add. And the next will be this one here, and that should be tag 10 with a capital T. The next thing we need to do is actually understand what an observability mode is, and it's one of the following values, either none, gauge, counter, histogram, or log. So I'm guessing that when we visualize this later, that determines what sort of visualization we get in either a gauge or some form of a counter, histogram, or a log. We can override the default sampling interval and queue size for each tag if we wanted to, but I see in that image that they're both at 500. So next we need to go to the add events page. And then we can press next and go to the review page. So nothing in the add events, and we can simply review it. So let's make sure that we can get to that point. So I can press next. So we're not going to add any events here, but looks like we can add things like state changes, alarms, conditions, and further things like that. Let's press next again and review. So our name is thermostat, and we have our endpoint profile there and a simulated thermostat. We have our custom properties that we added before, Contoso, Boiler, True, Seattle, and our tags with their sampling intervals, and our events with no events in there. So we can go ahead and press create now. And while that's creating, we can carry on with our tutorial. So the next thing we can do is verify that the data is flowing. So we can do this by verifying that the data is getting to the MQTT broker by using the MQTT-UI tool. In this example, we can run the MQTT-UI tool inside our Kubernetes cluster, it says. So I need to run the following command to deploy a pod that gives us MQTT-UI and Mosquito. So let's run this. So that created, and we could likely view those pods. And we can see we now have an MQTT client down at the bottom of our list now. Which is happily running. So the following snippet shows us the YAML that we applied here. So we don't need to dive too much into that, which is fine. So again, the configuration isn't secure. So a lot of this, I mean, IoT Operations isn't ready for production just yet anyway. So this is fine for what we're doing for this tutorial. So when the MQTT client pod is running, run the following command to create a shell environment in the pod we created. So we could see that that was running already. So let's copy that command. And there we are. So that's us dialed in via SSH to that particular pod. So, and at the shell for our MQTT client pod, we need to run the following command to connect to the MQ broker using the MQTT UI tool. And then we'll need to verify that the thermostat asset you added is publishing data to view the telemetry in the Azure IoT Operations data topic. Okay. So let's run this. Okay, so we can use the keyboard controls here, and we can use the enter button to go ahead with the cursor keys to select things. So press down a few times, and then we can press enter on this. We can actually see the messages are going up here. So it's gone up to 22, 23, 24. So we can actually see that there's data flowing here. So we can hit enter on the data and we can see that we have some data flowing. So over on the right hand side we have the history and we have the sequence number and some data flowing from our simulated PLC up to the Azure IoT Operations MQ service at the edge in our Kubernetes cluster. So that's good. So there is actually data flowing, but should it not be flowing, we can restart that pod. But we're fine with that. So the sample tags you added to the previous quick start generate message from your assets that look like the following. So that's actually what it looks like. We only got to the temperature portion of this, but actually there's a lot more in there. So next, discover OPC UA data sources by using IoT Acri. So Acri is the service that goes out and allows us to discover OPC UA assets that are connected to our edge device. And when we deploy IoT operations, we get Acri included. And we can verify these pods are running by running the same command that we normally run, but by grepping, which is filtering against the Acri service name. So let's quit this. Q. There we are. And then likely we'll need to Control and C or X or exit. Yeah, we can exit that. And then now we can run our kubectl. And we can see that we've got a couple of Acri services here, the agent itself and the OTel connector. So let's make sure that's what it expects. And yeah, that looks good. So we've got the Acri OTel collector and the agent daemon set present there. So that matches what we had. So the next thing we need to do in our Codespaces terminal is we need to apply a new configuration for the discovery handler. So let's go ahead and copy that and then return to our Visual Studio Code. It's missing the kubectl last applied configuration annotation, which is required for kubectl apply. Kubectl apply should only be applied to resources created declaratively. The missing annotation will be patched automatically. Okay. Hopefully that's not going to cause us any problems, but we'll see. So that applied this snippet here. And we can verify the configuration by running the following command to view the Acri instances that represent the OPC UA data sources discovered by Acri. Okay, let's have a look. It might take a few minutes, I see it says. Well, we have something. So what do we expect? We expect the output from the previous command to look like the following. So Azure IoT Operations, an Acri OPC UA Asset, true, and then nodes, and then age. So let's just double check that. But that looks like what we'd expect. So that appears to be working. And now we can use these resources in the local cluster namespace. So to confirm that Acri connected to the OPC UA broker, copy and paste the name of the Acri instance from the previous step into the following command. Okay, so let's run that. And we need to paste our instance name in here, it says, which is this. So we can paste that in here. And we have some JSON data popped out here. What do we expect? So we expect the command to look like this. The example excerpt from the output shows the Acri instance broker values and confirms that the OPC UA broker is connected. So some broker properties in that, and the endpoint profile, and an application for Boiler 2. So let's have a look. And so yeah, that looks like that matches. So we've got a spec and broker properties and an application URI of Boiler number 2. And we've got an asset endpoint profile with a bunch of JSON in it. So yeah, that looks like that all worked, which is great. So let's switch back over to the docs. And we can see that we're at the end of this tutorial now. So it's explaining here how we added an asset endpoint and defined an asset and its tags, and then the assets and the tags from the OPC UA server to make sure that the data is easier to use for the MQTT broker and downstream processes. And then we use the thermostat asset in the next quick start, apparently. So I look forward to seeing you in the next episode. Thanks very much, folks. Bye.